Today's lesson is going to cover notes on 4.3 and 4.4. 4.3 is the factor and remainder theorems. We are going to need to remember how to synthetically divide in order to do this. And we are first going to look at the remainder theorem. Let's see what the remainder is. We are going to say this is x cubed plus 0x squared minus 3x minus 1, and we are dividing by x plus 1. So this is the case. We don't really need a graph for this. We can synthetically divide by putting the coefficients 1, 0, negative 3, and then negative 1 past the remainder of the dividend. This is the dividend. And we need to set the divisor equal to 0, so x plus 1 equals 0 implies that x is equal to the negative 1, so that negative 1 has to be out here. Now, this right here is the divisor. So we start by bringing the first coefficient down 1 and multiplying times that outside negative 1, which gives us negative 1. So we're going to multiply first, and then we will add. So this is negative 1. Then we will multiply again times the outside negative 1 times a negative 1 is a positive 1. And that will give us a negative 2 once we add. And then negative 2 times a negative 1 is 2. 2 minus 1 is 1. So we multiply and we add. So we are making the expression mama, multiply, add, multiply, add, multiply, add. Just keep that in mind if you're doing this. You need to double check with the math. So what we can say from this is that x plus 1 is not a factor. And that x equals negative 1 is not a 0. So what our quotient was this was the x squared term, this was the x term, this was the c term, this is the remainder. So we should write this in quotient plus a remainder over divisor. So our quotient would have been x squared minus x minus 2 plus 1 over x plus 1. And we divide it. But clearly we do not divide either. Now for the next problem, we have m to the 5th minus 3m squared minus 20, and that is divided by m minus 2. So in this case, we need to write this out to be m to the 5th plus 0m to the 4th minus plus 0m cubed minus 3m squared plus 0x minus 20. So all of that is divided by m minus 2. So rewriting your expression first to make sure all the positions have a placeholder, even if it's 0, is very important. So we are going to do invert division bar. We're going to write in the coefficients. That's 1m to the 5th, that's 0m to the 4th, 0m to the 3rd, minus 3m squared, and then 0x and then now m minus 2 equals 0 implies we're testing 2 to be 0. So we'll put 2 on the outside. 1 down. 1 times 2 is 2, plus 0 is 2, times 2 is 4, plus 0 is 4, times 2 is 8, minus 3 is 5, times 2 is 10, plus 0 is 10, and then times 2 is 20, and we end up going even, so that makes us happy. So this is going to be x to the 4, this is going to be x cubed, this is going to be x squared, this is going to be x, and this is going to be a constant, and this is going to be negative. So since there was no remainder, that meant that m minus 2 is a factor, and that m equals 2 is a 0. And since we divide it evenly, we're going to say quotient is our answer. We don't need to say plus the remainder over the divisor because the remainder is 0. So we are just going to then not write that and just write the quotient, which was x to the 4th plus 2x cubed plus 4x squared plus 5x plus 10. That was the quotient of that division product. Positive unity. So basically, we have a quicker way to find the remainder, and the remainder there, it says if you substitute the opposite of the factor into f(x), the answer you get is the remainder. If the remainder is 0, then the binomial is a factor, states the factor theorem. So to test our last theory, we could have just simply plugged -1 into the polynomial in number 1 and found out what our remainder was. Now, just for simplified purposes, I will just simply plug in, I will say -1 cubed minus 3 times a -1, and then minus 1. If you enter, and our remainder was 1, just like it was when we did synthetic division. Similarly, we could have done the same thing to number 2. We could have simply plugged 2 into the equation. So we could have said, parentheses, 2 raised to the 5th. We could have said minus 3 times 2, and that was squared. And we could say minus 20, the intermediate 0 as the remainder. So that's basically what they're saying. They're saying that the remainder theorem says is if you substitute in the opposite of the factor, which is the possible 0, the answer you get is the remainder. The factor theorem says if the remainder is 0, then the binomial is a factor. It says, so use the remainder theorem to find the remainder when 2x cubed minus 3x squared plus x is divided by x minus 1. So first have to find out the opposites of x minus 1 equals 0. Means we are going to plug in 1. So that's going to be 2 times 1 cubed minus 3 times 1 squared plus 1. So this becomes 2 times 1 minus 3 times 1 plus 1. So that becomes 2 minus 3 plus 1, and that's going to equal 0. And that's what we discussed. So you don't need a graphing calculator. You can just simply just do algebra and plug that stuff in. You get 0. Then we found out that x minus 1 is a factor. Therefore, x minus 1 is a factor. We can also say that x equals 1 is a 0. And you can call them roots, you can call them solution, you can call them x-intercepts. Okay, we could also even say, if we declare this to be a function, that f of 1 was also equal to 0. If we said that this was equal to like f of x. Pause if you need to, I'll go into the next screen. Now, for these higher order polynomials, if I give you a 0, then you should be able to simplify the depressed polynomial once you do your division synthetically. So we have x cubed plus 2x squared minus 16x minus 32 is equal to f of x. And we're going to say, given that f of negative 4 is 0, okay, so we're saying that's a 0, let's find all the factors. So one factor is the given. So if f of negative 4 is equal to 0, then that means x is equal to a negative 4. That means x plus 4 is one of the factors. Now, when we look at the rest of this, we can see that synthetically we will divide, and we will say that negative 4 goes out here, and then we have a 1, we have a 2, we have a negative 16, and we have a negative 32. So we will bring down the negative, we will bring down the 1 and multiply by the negative 4, so that's going to be negative 4, and then negative 4 plus 2 is a negative 2 times a negative 4 is a positive 8, and a negative 16 plus 8 is a negative 8 times a negative 4 is a positive 32, and that's 0. So this is the depressed polynomial, so it should be x squared minus 2x minus 8, right? That's the way our polynomial should be. Now we should be able to solve that by either factoring, or we should be able to solve it quadratic formula, those types of things. So it looks like it factors. It looks like I can say, okay, with 8 there is a 1 and an 8, there's a 2 and a 4. I'll probably use the factors of 2 and 4, so I'm probably going to say like x minus 4 times x plus 2 are my factors that make that trinomial. And so we should have our 3 factors that said find all the factors. I think we just discussed all the factors. So those are all the factors, and they are linear. Okay, and if I multiplied all 3 of them, I should get back my original polynomial. Positive. Okay, you try this one. Find all the factors of x cubed minus 7x plus 6 equals 0, given f of 2 is equal to 0. So I'm giving you one of the zeros. You find the other factors. You find all 3 factors. Let's go and pause it and check your work. So x minus 2 would be a factor. So 2 would go on the outside. We have 1, 0, 7, 6. Keep in mind here that this is x cubed plus 0x squared minus 7x 6, 0. And you can also say that it's just equal to fx. So we're going to bring down the 1 times 2 is 2 plus 0 is 2 times 2 is 4 minus 7 is negative 3 times 2 is negative 6 plus 0. So this becomes x squared plus 2x. Well, that should be minus 3. And that appears that it would factor. So I'm going to say x plus 3, I'm going to say x minus 1. And then we have x minus 2. So we've just found all the factors of that. But we needed some information to do it. Pause if you need to. last but not least, they said find the value of k, so that the remainder of x cubed plus 3x squared minus kx minus 24 is divided by x plus 3 is 0. So now, if they're saying that this is a factor, then they're saying that x must equal negative 3. And so basically what they're saying is I can say negative 3 cubed plus 3 times a negative 3 squared minus k times a negative 3 minus 24. Let's plug all that in like that. All of that should equal 0. So this gives us a negative 27. And this gives us a positive 27. And this gives us plus 3k minus 24 is equal to 0. So then we're going to say 3k equals 24. Therefore, k is equal to 8. Therefore, our original polynomial should have been x cubed plus 3x squared minus 8x minus 24. We could indeed check that by saying synthetically, if we put the negative 3 out here, our coefficient would be 1, 3, negative 8, negative 24. And we brought down the 1, negative 3. We get 0. 0 times a negative 3 would be 0. That would be negative 8 times a negative 3 would be a positive 24. And so negative checks out. So I found the value of k. And I checked my answer. Pause if you need to. We'll go into 4.4. So now we're ready for the notes for section 4.4, which covers the rational root theorem and Descartes' rule of signs. Given any polynomial, this term is considered to be the constant. This term is considered to be the leading coefficient. So the rational root theorem says that all the possible rational roots are discovered by finding all the factors of the constant factor divided by all the factors of the leading coefficient. So we have to create that condition and expressly state all of the possible factors. Find all the possible rational roots for 6x cubed plus 11x squared minus 3x minus 2. So we have to think of the constant. What are the factors of 2? Well, the factors of 2 are just 1 and 2. And the factors of 6 are 1, 2, 3, and 6. So we create a fraction with the constant factors on the numerator and the leading coefficient factors in the denominator. We got to say plus or minus. Now, so then we list them. So we're going to start out with saying 1 divided by 1 is plus or minus 1. 1 divided by 2 is plus or minus 1/2. 1 divided by 3 is plus or minus 1/3. And 1 divided by 6 is plus or minus 1/6. We will then say 2 divided by 1 is 2. We will say 2 divided by 2 is 1. That's already there. We will say 2 divided by 3 is 2/3. And we will say 2 divided by 6 is 1/3, and it's already there. So if there are any real possible rational roots, okay, then they have to come from this area. They have to come from this area. Pause if you need to. So for this example, we're going to find all the roots for x cubed plus 8x squared plus 16x plus 5 is equal to 0. So in this case, I'm going to say, well, the constant is 5. The factors of 5 are 1, 1, and 5. And the leading coefficient is 1, so the factors of 1 are just simply 1. So remember, it's going to be constant divided by leading coefficient. So plus or minus 1 plus or minus 5 over plus or minus 1. So my possible rational roots are going to be plus or minus 1 or plus or minus 5. So in this particular case, you need to perform synthetic division. Now, synthetic division can be done more shorthand to help you with this. Because once you find it's a 0, then you are going to divide the 0 into this polynomial. So let's say that this is going to be 1, 8, 16, and 5. And we will start out with a 1. So we're going to divide by 1. So that means we are going to bring the 1 down. And 1 times 1 is 1, plus 8 is 9, times 1 is 9, plus 16 is 25, times 1 is 25, plus 5 is 30, so that didn't work out. So we'll try a negative 1. 1 times a negative 1 is a negative 1, plus 8 is 7, times a negative 1 is a negative 7. Plus 16 is 9, times a negative 1 is a negative 9, plus 5 is a negative 4. That didn't work out either. So now we'll try 5. So we'll bring down the 1. 1 times 5 is 5, plus 8 is 13, times 5 is 65. 65 plus 16 is 83. So we can see this is sort of getting out of hand here. So 83 times 5 is 415, so this is going to be 420. And that didn't work out. So we'll try negative 5. So we'll bring down the 1. 1 times a negative 5 is a negative 5, plus 8 is 3, times a negative 5 is a negative 15, plus 16 is 1, times a negative 5 is a negative 5, plus 5 is 0, so it gets checked out. So negative 5 is a 0. Good. Okay, so now we know that. So we are going to perform synthetic division with negative 5 on this polynomial up here. So now we know what's left is, oh, we've already done that, I'm sorry. So we're going to say this is x squared, and this is plus 3x, this is plus 1. So now we need to find all the roots, all the solutions. So we know one of them is negative 5 because it had a remainder of 0. So we're going to say x squared plus 3x plus 1 is equal to 0. And we're going to do the quadratic formula on this because I don't see it factoring. So a is equal to 1, b is equal to 3, and c is equal to 1. And then b squared minus 4ac is equal to opposite, or 3 squared minus 4 times 1 times 1. So that's going to give me 5. So now that means that x equals opposite b plus or minus the square root of 5 over 2 times 1. So x is equal to a negative 5. X is equal to negative 3 plus root 5 over 2 and x is equal to negative 3 minus 5. I've just found all the roots. I'm going to these the roots, zeros, solutions. You can call them the x-intercepts. So you have all those different names you can name. Okay, what I'm discovering. Okay, so now we're going to find the zeros for x to the 4th plus 4x cubed plus 3x squared minus 4x minus. So basically, I'm going to try to find the possible rational roots. And so the constants, possible rational roots are plus or minus 1, plus or minus 2, plus or minus 4. And leading coefficients are plus or minus 1. So that means we can do plus or minus 1, plus or minus 2, or plus or minus 4. And we know that we can synthetically divide so this will be a 1, this will be a 4, this will be negative 4, this will be negative 4. And I'll start out with these. I'll do a positive 1 first. I'll start with 1 here. Bring down my 1. 1 times 1 is 1, plus 4 is 5, times 1 is 5, plus 3 is 8, times 1 is 8, minus 4 is 4, times 1 is 4, minus 4 is 0, so that's a good one. So we have a 0 there. Now we'll do it again. Okay, now I have to bring down the 1 from the top again, so we're going to put negative 1 here. So 1 times a negative 1 is negative 1, plus 4 is 3, times a negative 1 is negative 3, plus 3 is 0, times a negative 1 is 0, minus 4 is a negative 4, times a negative 1 is 4, which is 0, so 1 and negative 1. So that's really nice. So now we're going to do, well, we probably have enough to where we can do some synthetic division now. So basically, I know those two are zeros. I can then, from here, I can try a 2. Let's see what happens with 2. So I bring down the top of 1. 2 times 1 is 2, plus 4 is 6, times 2 is 12, plus 3 is 15, times 2 is 30, minus 4 is 26, times 2 is 52, minus 4 is 48, so that's no. Let's try negative 2. And so with negative 2, we are going to bring down 1. 1 times a negative 2 is a negative 2, plus 4 is 2, times a negative 2 is a negative 4, plus 3 is a negative 1, times a negative 2 is 2, minus 4 is a negative 2, times a negative 2 is a positive 0, so we have a lot of them. So basically, I know right now that I have 3 of my possible 4 solutions, and chances are one of those just might be a double root. So I think I have enough to where I can check this out. So if you bear with me, I'm going to go to another screen. And I'm going to use some of these zeros with the original and depress the equation until it's a quadratic. So I'm going to start out with a negative 2, and the synthetic division is being performed on the original polynomial. So basically -2 is being done on the original polynomial. And you'll probably understand that you've seen this line before. This was in the prior work we saw here. And what happens is now as we perform synthetic division, again, using one of the other roots, in this case, -1 I'm using here. I'm performing synthetic division again. So this was a 4th degree. And now down here, this became a 3rd degree. Now this became a 2nd degree. So this is a quadratic. So I can really just, as soon as I get it to become a quadratic, I can just solve this x squared plus x minus 2 is equal to 0. I can solve that by factoring x squared minus x squared plus x minus 2 equals 0, which those factors are going to be x plus 2 and x minus 1 equals 0. So therefore, x here is equal to a -2, and x here is equal to 1. And up there, we already determined that we have already used -2. And we've already used x equals -1. So we have all 4 zeros. And -2 was a double root, or has a multiplicity of 2. However you want to look at it. Positive. So again, positive you need to, but I'm going to the next screen. So when we performed all these synthetic divisions, I could have really stopped after these two and synthetically divided twice on the original equation until I made the quadratic. Just keep that in mind. So you can write this one down and do this one on your own, but the tape has gone too long, so I need to get to Descartes' rule of signs. So pause if you need to. Okay, so for Descartes' rule of signs, it tells you the number of possible positive and negative real zeros there are. Okay, to find the positive real zeros, count the sign changes in the original function. To find how many negative possible real zeros there are, count the sign changes in the opposite of the original function. So in other words, you have to plug in -x into that. And now complex conjugates show up in pairs, so we always have to subtract 2 from our answer until we get to a negative number. We can't have a negative number of zeros, so we need to decrease it by 2 until. So list the number of positive and negative real zeros of 2x to the 5th plus 3x to the 4th minus 6x cubed plus 6x squared minus 8x plus 3. So basically, what we do is we look for sign changes. Okay, so the first term is positive and the second term is positive, so there is no sign change. The second term is positive, but the third term is negative, so there is a sign change. Now, from the third term to the fourth term, there's a sign change. From the fourth term to the fifth term, there's a sign change. From the fifth term to the sixth term, there's a sign change. So it's a total of 4 sign changes. So that means we could have a possible number of zeros of 4 or less than that by an even number without going negative. So 4 or 2 or 0 possible positive zeros. In the next situation, we put in a -x. That means odd exponents values sign will change. If you just remember our symmetry test, this is sort of basically what we're doing. We're putting in a -x. So we notice the first term goes negative, the second term doesn't change, the third term goes positive, the fourth term doesn't change, the fifth term goes positive, and the last term does not change. So with those 3 sign changes that we just made, because we substituted a -x, we only have 1 sign change for the possible negative zeros. So that means we have only 1 possible number of negative real zeros. Positive. Okay, I'm going to the last slide. List the number of positive and negative real zeros and find them. Okay, so you do this one on your own. So we look for the sign changes in x to the fourth minus 5x squared plus 4, and there are in fact two sign changes. So the possible number of positive real zeros are 2 and less than that by an even number without going negative, so 2 and 0. Now, we can't change the signs in this problem because the exponents are even, so the signs won't change. So basically, the answer will be the same for negative real zeros. So the possible number of negative real zeros are 2 or 0. That ends the lesson.